Welcome to Correct Science. Today we are going to solve amazing math questions on indices. Without wasting my time, let's take a look at the questions. Here are the questions. First one, we are supposed to simplify this expression 1 plus x to the exponent half minus 2x times 1 plus x to the exponent negative half on 1 plus x to the exponent half. So you can pause the video to try it on your own. When you are done, you follow with us. Now find the value of x in the following. So here are the questions. You can pause the video, try it on your own, and later watch the video to clarify your answer. We'll pause the video now. Without wasting my time, let's now delve into the solution. Let's start with the first one. We're expected to simplify this expression. How do we go about it? Okay, so let's first make an observation. Realize that here we have 1 plus x to the exponent negative 1 on 2. What can that do for us? Okay, so we know that when we have a to the exponent negative n, it's the same as 1 plus 1 over a to the exponent n, right? If that is so, then 1 plus x to the exponent negative 1 on 2 is the same as 1 over 1 plus x to the exponent negative, 1 on 2. And here we have some 2x here, so it will be 2x over 1 plus x to the exponent half. So when we get that, you might be asking, what can that do for us? So we'll see in a few seconds to come. Okay, so this is what it will do for us. This is what it will do for us. So you see here, we've written it this way. And now we have something to compute. So something like this, a minus b on c was ac minus b on c. So b times 1, right? Yeah, so that's what we've done here. To get this one. We get 1 plus x to the exponent half, multiply 1 plus x to the exponent half minus 2x on 1 plus x to the exponent half on 1 plus x to the exponent half. Wow, wow, wow. How would this shape out to be? Okay, so right at the top here, we see something. See 1 plus x to the exponent half, multiply 1 plus x to the exponent half. And we know that a to the exponent m times a to the exponent m equals a to the exponent m plus n. So having 1 plus x to the exponent half, multiply 1 plus x to the exponent half. 1 plus x to the exponent 1 is the same thing. 1 plus x. Okay. So we can further reduce this. And how would that look like? Let's see. So this is how it will look like. 1 plus x minus 2x on 1 plus x to the exponent half divided by 1 plus x to the exponent half. And now we know that b over a is the same as b times 1 over a. So here we brought it out. The denominator was a. Now we said b times what? 1 over a. So let's say this whole thing is our b. That's what we've done here, right here. So now how do we continue? All we do is to multiply the denominators. And here 1 times this, it will still give you the same thing. So 1 plus x minus 2x on 1 plus x to the exponent half, multiply 1 plus x to the exponent half. And we've already deduced that 1 plus x to the exponent half, multiply 1 plus x to the exponent half will give us 1 plus x. And the top two, what do we get? So we get x minus 2x. And that's what? Negative x minus x. So 1 minus x. So I'm sure you'll be getting our answer by now. So the correct answer is 1 minus x on 1 plus x. X is not equal to negative 1. Simple. I hope you got it. Let me know in the comments below. Now let's look at the second question. The second question. Yes. We have 4 to the exponent x plus 4 to the exponent negative x equals 17 on 4. So the first thing we would like to do is to clear by multiplying through by 4. Now we have to make an observation as well that 4 to the exponent negative x is of the form a to the exponent negative m. So we have 1 over what? A to the exponent n. So 4 to the exponent negative x equals what? 1 over 4 to the exponent x. That's one observation we have to make. So let's go back to what we were saying by clearing through by 4. We have 4 multiplying through. So the 4 will cancel the 4 here. The 4 will cancel the 4 here. Now the 4 will multiply the other one. Yeah. So we get 4 times 4 to the exponent x plus 4 times 1 on 4 to the exponent x equals 17. We can clear another fraction here again. So we can multiply through by this denominator, which is 4 to the exponent x, throughout the whole thing. When we do so, this is what we are going to obtain. We are going to get 4 times 4 to the exponent x times 4 to the exponent x plus 4 times 1 over 4 to the exponent x times 4 to the exponent x equals 17 times 4 to the exponent x. Now we can rewrite this as sending the 17 times 4 to the exponent x to the left hand side of the equation as 4 times 4 to the exponent x squared minus 17 times 4 to the exponent x plus 4 equals 0. Now let's represent 4 to the exponent x by any variable we want. So mine might be y or might be z or something. So I'm using y here. So let y be equal to 4 to the exponent x. Now we have 4y squared minus 17y plus 4 equals 0. Then when we do this, we get y minus 4 times y, 4y minus 1 equals 0. So you get y equals 4 or y equals 1 over 4. You get y or 4 equals 1 over 4. And we know 1 over 4 is equal to 4 to the exponent negative 1. And 4 equals 4 to the exponent 1. And we know that when we have the same base, then the powers are also the same. So when we express 1 over 4 as this, then it means x equals 1 or x equals what? Negative 1. We are done. These are the roots of this equation. Okay, what else? Oh yeah. So the solution is already showing. But how do we approach the solution? So let's see. We have x squared minus 5x minus 5 to the exponent x squared minus 3x plus 2 equals 1. Someone might be wondering, so how do we get here? I'm showing the solution, but how do we get the solution of 4 roots? Don't think too much, but you have to actually think. So what do? We know that a to the exponent 0 equals 1, provided that a is not equal to 1. It's not equal to 0, sorry. And if you want to know why a to the exponent 0 equals 1, okay, let me use a few seconds for that. Let's say we have a to the exponent and we divide by a to the exponent 2 is the same as a to the exponent 2 minus 2. So we get a to the exponent 0, right? And now we know from basic mathematics that we have one number over the same number where the number is not 0. Then the number cancels itself to give us 1. So a to the exponent 0 equals 1. Simple. So these two could have been any other number. And we have a to the exponent 0 giving us what? 1. Now the reason why it shouldn't be 0, a shouldn't be 0 is that when we have 0 to the exponent 0, it means 0 to the exponent 2 over 0 to the exponent 2 or any other number as the exponent of 0. And we know 0 squared is 0. 0 over 0. I'm sorry, but Your calculator will not give you anything. It's indeterminate. Okay, that's just by the way. So knowing that a to the exponent 0 equals 1, it means x squared minus 5x minus 5 to the exponent 0 equals 1. So you can write this expression and say that x squared minus 5x minus 5 to the exponent x squared minus 3x plus 2 equals x squared minus 5x minus 5 to the exponent 0. Wow. Since the bases are the same, we can equate the powers, the index, the exponents. So we have x squared minus 3x plus 2 equals 0. Now it has become so simple. You can just use quadratic equations to solve this. We know 2 is this, has factors of -1, -2. And when we add them, we get 3x, -3x. Now, if we are in a speed contest, you can just negate the 2 to get your answers. Anytime you get a factor, just negate the 2 to get your answers. Then you just say x equals 1 or x equals 2. But let's do it step by step. So we have x minus 2 times x minus 1 equals 0. X equals 2 or x equals 1. Simple. Okay, here you can see that there are 4 roots, but we've only gotten 2. So how do we get the other ones? You might be wondering. Okay, so we know that 1 to a to the power a equals 1. For now, we can just make that statement that 1 to almost every number will give us 1. Because 1 times 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 1 will give us 1. Simple. So what can we say here? That anytime we equate x squared minus 5x minus 5 to 1, and we raise to any number, then we will get 1. I hope it's clear. It means if we equate this whole expression to 1, we find the roots. Then any number we put into this to give us 1 to any other number give us 1. Okay, I'm not sure. I hope it's clear. Okay, I hope it's clear. I hope it's clear. Yeah, I hope it's clear. Okay, so this is what we mean. Yes. We have x squared minus 5x minus 5 equals 1. X squared minus 5x minus 6 equals 0. And we have x minus 6 multiply x plus 1 equals 0. So we have final answer to be x equals 6 or x equals -1. So out of this, we have 4 solutions. I want you to test them one by one on your own and check if all of them work. But for now, these are our roots. Very simple question, right? Let's look at the. Okay, so here we have 2 on 5 to the exponent 3x minus 4 equals 5 on 2 to the exponent 2x plus 1. I'm sure this will be one of the easiest questions among them. But how do we go about it? The one thing we should know is that 2 on 5 has a relationship with 5 on 2. What is that relationship? Realize that 2 on 5 equals 1 over what? 5 on 2. 1 over 5 on 2. Don't you see this? So don't you think if we raise 5 on 2 to the exponent -1, we'll get 2 on 5? And we'll have an equal base. So let's try that and see. Let's try that and see. So we have 2 on 5 to the exponent 3x minus 4 equals 5 on 2 here, 2 on 5 to the exponent -1 multiply 2x plus 1. Very simple. So here we have an equal base. You can equate it and get the answer. I don't need to talk much. And this is our final answer. X equals what? 3 on 5. Simple. I'm sure this is the easiest question so far. Thank you very much. Now, let's move to the next question. Let's have a look. Okay, so for this one, we have 3 to the exponent x on y equals 1 on 81. And we know 81 is equal to 3 to the exponent 4. And we know this will give us what 3 to the exponent negative 4. Simple. Meaning that 3 to the exponent x on y is equal to 3 to the exponent what? Negative 4. Since the bases are the same, we can equate the powers. We have x on y equals negative 4. Now we are told to find the ratio of x squared to y squared. What do we do next? Square both sides and see what will happen. We have x on y all squared equals negative 4 squared. And we know that a over b to the exponent n equals what? A to the exponent n over b to the exponent n. So x on y all squared equals 16, meaning that x squared to y squared equals 16. So the ratio is what? 16 to 1. Simple. We are done with this one. Now let's look at 3b. 3b, we have a fine question. And this is it. 4 to the exponent y on x equals 2 to the exponent negative 6. I told to find the ratio of x squared to y squared. How do we go about it? So we like to express it as a common base. So we know that 4 to the exponent half equals 2. And why do we say so? So we know that anytime we have a to the exponent m on m, the same as the nth root of a to the exponent m. Sorry for the there's no space. So, okay, to the exponent m. Good. So we have root 4. And we don't like to write a 2 here because it's just root 2. Root 2 to the exponent of 1. And that's so 2. Okay. So when we do this, then we are expressing it as a common base. So we have 4 to the exponent half multiplying negative 6. 4 to the exponent y on x equals 4 to the exponent 1 on 2 multiplying negative 6. And that will give us 4 to the exponent y on x equals 4 to the exponent negative 3. We can equate y on x with what? Negative 3 since the bases are the same. So we have y on x equals what? Negative 3. We are told to find x squared to y squared, the ratio of x squared to y squared. But here we have y on x. Later we'll get to know how we can go about it. Let's now square both sides and see what will happen. So we have y squared on x squared equals negative 3 squared. And that's y squared on x squared equals 9. Okay, we know that x squared over y squared is equal to what? 1 over y squared over x squared. Why do we say so? So we know this is divided by x squared. So yeah, 1 over y squared divided by x squared. And we get x squared over y squared. When we find the reciprocal of both sides, we get x squared over y squared. That will be our final answer. So the ratio of x squared to y squared is 1 is to 9. The video has become so long, so we'll end it very soon. Okay. Okay, so for the fourth question, we have root 3 to the exponent 3x equals 9 to the exponent 1. Let's express it as a common base. What would that do for us? So let's express it as a base of 3. And we know root 3 equals 3 to the exponent half and 9 equals 3 squared. So we have 3 to the exponent half multiplying 3x equals 3 to the exponent 2y. We have 3x on 2 equals 2y. Since the bases are the same, we can equate the powers. Okay, so we have 3x equals 4y. How do we find the ratio of, x to y? You might be wondering. Okay, so let me show you something here. We have ax equals by. We are told to find the ratio of x to y to be equal to the coefficient of b over the coefficient of a. Why do we say so? Because if you cross multiply, you see you get the same thing. Yes. So that's how to do it. And if you are told to find y over x, the coefficient of x over the coefficient of what? Y. Simple. So here too, if we want to find the ratio, then we have to do something similar. We have, okay, we're told to find y on x here. So we have y on x equals the coefficient of x over the coefficient of y. That's what, 3 or 4. Very simple. Thank you very much for watching this video. I'm sure you saw a certain question in the thumbnail. The answer to that question is 2. Do you like to know how we solve it? Let me know in the comment field. So it is okay for today. Bye bye.